Hello, everyone. Today, I'm going to explain the debugging and operation of the pitch system. Next, let's learn about the typical faults of the pitch system and their handling. Let's take the simulated wind turbine as an example. Analyze typical fault phenomena and handle them. First, observe the frequency at which the indicator light flashes. The faults reported by Stanton are generally characterized by simultaneous flashing or one slow flashing and the other dual flashing. The normal operation is alternating dual flashing. 2. When a DP communication connector reports a fault, it usually indicates that the BF red light is on or the RD and TD green lights do not flash. Normally BF doesn't light up. Both RD and TD flashed. The faults of RD and TD are generally due to the lack of communication between the Stanton and the DC brushed motor speed regulator. 3. The fault report of the DC brushed motor speed controller is that the indicator light flashes slowly. The common fault is that there is no communication with the DP communication connector. This leads to a normal flash. 4. The fault of the encoder conversion module is that both the A and B signal lights are on simultaneously or neither is on. Normally, only one of AB lights up when there is no rotating encoder. When rotating, both A and B light up in a flash state. 2. Fault treatment. DP communication failure. 1. Whether the left and right switches of the DP communication connector are in the correct position. 2. Check whether the wires in the DP communication plug are properly connected and whether the green A and red B metal sheets are in contact with the shielding layer. 3. Whether the DP communication plug is properly connected to the signal line of Stanton. 4. Check whether the communication line between the DP communication connector and the DC brushed motor speed controller is properly connected. 5. Whether the left and right addresses on the DP communication plug are above -3 or above -4. 3. Fault of variable pitch motor. 1. Whether the positive and negative power lines of the pitch motor are correctly connected. 2. If there are no issues with the wiring, check whether the DC brushed motor speed controller has input voltage and output voltage signals. At the same time, determine whether it is communicating with the DP based on the flashing of the indicator light. 4. Encoder failure. 1. The encoder has a volt positive and negative power line and the encoder AB signal line has a total of 4 lead wires. 2. First, turn the encoder. Observe whether there is feedback from the AB indicator light of the encoder conversion module. There are 3 situations. 1. The AB indicator light is not on. The fact that all the circuits are correct indicates that the encoder has been burned out. 2. The AB indicator lights light up simultaneously. In the absence of a rotating encoder, it indicates that the AB signal lines of the encoder are connected incorrectly. 3. When one finger rotate. If all the circuits are correct, it indicates that the encoder may have been burned out. 5. Limit optical fiber failure. A limit switch is an electrical switch used to define the limit position of mechanical equipment's movement. The components of a limit switch are a stop block and a switch. The installation position of the line position switch is the 91° and 95° line position optical fibers. Fault 1. Check whether the positive and negative power lines of the 91° and 95° pitch optical fibers are connected correctly. Whether the signal lines are connected correctly. 2. Adjust the trigger sensitivity reduction value of the optical fiber signal amplifier. Enhance the trigger signal. The signal is full until the red light comes on. At the same time, check whether the input and output of the optical fiber line are connected correctly. If connected wrongly, the light from the optical fiber is relatively weak. 3. Check whether the optical fiber cable is bent and damaged. The above is the typical fault phenomenon and handling of simulated wind turbine units. I hope all the students can master and understand it. Thank you all.